All right, but let's get into it here. So I probably got a little carried away with all the stuff on there about slope. You know what slope is, I am 100% sure of it, but let's just review and recap and take a look at some of these pictures. There's really nothing for you to fill in on this front page of the notes, just a few things I want to point out to you. So of course, slope measures the steepness of a line, or how quickly it rises or falls. Also, the sign on the slope, positive or negative, tells you which direction the line is going to go. Positive slopes rise to the right, negatives fall to the right, as you can see in these lovely pictures here. And I know you know these lovely formulas. So if I'm given the picture of the graph, clearly I'm just going to count rise over run, how much up and down first. And then, of course, if I'm given two ordered pairs, I'm going to use my old school 8th grade math formula for slope, y2 minus y1 over x2 minus x1. Remember, the y2 minus y1, that's what this is showing you, the change in the y coordinates, the difference in the vertical change. And then, of course, the run, x2 minus x1, your horizontal change. That's what you're comparing, rise over the right. You know this, I know. Okay, so just to kind of show you some examples of slope, of course, why slope's important. We use slope in the real world. Slope of a ramp, maybe some of you skateboard, slopes have a ramp before, pitch of a roof, grade of a road. Like sometimes you'll see signs that say like a 12% grade or something, 12 over 100, rise over the run. So just another examples of where slope pops up in the real world. I know you know this, slope of a vertical line not defined. Just because think about your vertical lines, you've got no run, 0 under the line, undefined. Just pointing out some stuff, you know. And of course at the bottom of your notes here are all these very lovely pictures. Positive rises, negative falls. 0 slope is your horizontal because of course you have no rise, so the 0's on top. And then no slope, or really probably a little better, is undefined slope, your vertical line, because there's no run on that. All stuff we know. Okay, let's do it. Find the slope of the line that passes through those points. Okay, so no graph grid, so all I'm going to do is use my formula, my y2 minus y1 over x2 minus x1. And it's up to you if you want to label the points. I'm going to label them just for dramatic effect. So y2, my second y is 5, minus the first y, second x, minus the first x. And we're just going to simplify. So 5 minus 1, I've got 4, 8 minus 2. And last but not least, let's reduce it. They're both even, so I'm going to cut them by 2. I have a good feeling we all know how to calculate slope. Okay, moving on. Sketch the lines through the point -1, 3 with those different slopes. So every single line is going to go through this point. So I'm going to plot that first, -1, 3. And then I'm going to start marking out these lines. Now, I'm going to color code it. Let's do 2 in blue. So I'm thinking about that in fraction form, 2 over 1. So the rise is 2, run 1. So start at the, well, my point's red. Start at -1, 3, up 2, right 1. And I just put several points on because we've all seen my drawing skills. So I need a few to kind of help me draw it straight. Got it. All right, next one I'm going to do in green. So -1/2. So -1 on the top. So rise, down 1, run, right 2. Starting at my red dot. And again, I don't care how many points you put on. I just kind of put enough on so I can draw it nice and straight, if I can. All right, and the final one, I'm losing my red dot there. I'm going to put them on there. My final slope, 0. I'm going to do that in black. So remember, 0 is your horizontal line. So super easy. My red dot, I'm just going to draw my horizontal line through it. Oh, pretend that's straight. It got away from me. So just a little quick recap on how to count slope out on the graph grid, which I'm sure you all already knew. Cruising on. All right, slope-intercept form the equation of the line. mx plus b, there's nothing exciting or new or wild here. M is the slope, b is the y-intercept. So write the equation in slope-intercept form of the following. So we need the slope, we need the y-intercept. And I can get all of that information off of the graph. Now, y-intercept, that's probably the easiest. It's the y-axis right here, -4. Now, slope. you can pick any 2 points on the line and count the slope. But of course I'm looking for nice points that like hit in the corner, oh, there we go, corner of the graph grid, and I'm going to count the slope between those. So down, 1, 2, 3, 4, and I'm going right 3. Or of course, just, you know, for the love of math, you can count from the bottom to the top. You're going up 4, left 3. You get the same fraction. All right, final answer, I need the equation of the line, so I'm going to write it out nice and pretty. Y equals the slope times x, and then my y-intercept. Any questions on that one? Kind of a nice lesson for a Monday. All right, I love B. They give you everything for B. I just have to write my equation. Y equals the slope times x and my y-intercept. Crushing it for B. Right. Any questions on those guys? All right, so the next question or next situation we need to deal with is what if, because these are obviously very simple, what if you do not have your y-intercept? You don't have the picture of the graph, so you don't know where it hits the y-axis, or they didn't tell you the y-axis. If that is the case, then we're going to use what's called point-slope form. So use the name. Any point on the line, some random point, not the y-intercept, just a point, and of course the slope. We all know how to do the slope. So point-slope form, of course, this lovely formula. Maybe you've seen that. Hopefully you've used that in the past. Obviously, we'll start with the easy thing. M is the slope, clearly. And then what you're also replacing in this equation is the x1 and the y1. So we can circle those. And you can see those are the ordered pairs of the point. So the 3 numbers that I'm going to plug into point-slope form is the slope and then the coordinates of the points. From there, we can distribute, solve, do whatever we got to do. Find an equation of the line. Oh, okay. They want the final answer in slope-intercept. Well, I'm going to worry about that in a minute. Through this point and the slope. So I'm looking at my point, and I'm like, Yahtzee, that's not my y-intercept. If you plot it, it's not on the y-axis. So I cannot start in slope-intercept form. I got to start in point-slope. So here's my x1, y1. Slope, of course. So I'm going to just plug them in. Y minus the y coordinate of the point, oh gosh, -3. So I'm going to make that a plus in a minute. Equals my slope, x minus the x coordinate. Now, if my direction said write the equation in point-slope form, I'd be done. I wouldn't do anything else. I'd circle it and go on my way. It wants it slope-intercept. It wants it solved for y. So I'm going to distribute, do all that good stuff. So let's take -1/2 through. -1/2 times x. -1/2 times -1. Positive to the half. You know I love a good fraction. And then last but not least, to get y alone, I'm going to subtract 3. All right, what is 1/2 minus 3? That's the question. Half minus 3, -2.5. Now, if I asked you for funzo, what's the y-intercept? You could tell it to me. What's the y-intercept? Yeah, -2.5. Okay. So if they just give you a point, not the intercept, the point, you have to start in point-slope form. And just, as always, read the directions closely so you know what style your final answer should be in. If they said point-slope, we would be done in one line. It wouldn't have been a big deal. All right, find the equation of the line in slope-intercept form through those points. Okay, all right. So I'm looking at my points. My first problem is they didn't even give me the slope. Not that that's that big of a deal, but we're going to have to do a little y2 minus y1 over x2 minus x1, and we're going to have to find it. And we can find slope, that's not a big deal. So y2, -4, the second y, minus the first y, minus 2, I like to write not a 3, 2, over x2 minus x1. So I'm just going to simplify. So I have a -6 over reduce it. So the next question is, was I mean or nice to you? Are either of those points my y-intercept? And I'm like, -1, 2, that's not on the y-axis. Neither is 3, -4. So that means we have to use point slope again. It doesn't matter which point you use. I might use the first one, Owen might use the second one. We're gonna have the same final answer when we're all said and done. I just look for small numbers. I'm just gonna use the first one. So I'm gonna do y minus the y coordinate, that lovely fraction slope, x minus the x. Now, final answer in the directions, it wants slope-intercept form, so unfortunately I'm still working. I'm gonna have to distribute, do all the good stuff. So -3/2 x, -3/2 times 1. And last but not least, I'm gonna add 2 on over. So for those that miss geometry, here you go today. All right, negative, I'm gonna think of that as -1.5. What's -1.5 plus 2? 1/2. Got it. And if I asked you for the y-intercept, you could now tell me it is 1/2. All right, any questions on that side? I love it, it's like geometry, too easy. Okay, vertical and horizontal lines, kind of the next thing we're gonna get into. So vertical lines, of course, up and down. Horizontal lines run left to right. Of course, the slope on a vertical is undefined. Slope on a horizontal is 0. Just one of those fun-filled things out to you. Find the following problems involving, okay. So A, an equation of a vertical line through 3, 5. Now, I love vertical and horizontal because there's really no work for them. If you think about vertical lines, every vertical line always hits the x-axis. It's always going to intersect your x. That's why if you look up here, your equation is always x equals. And it's going to hit this point. So, a little common sense here, x better be hitting 3. If I asked you for the horizontal line, horizontals always hit y. It would be y equals 5. So you just have to keep them straight. Vertical is x equals, horizontal y equals. Graph the equation x equals 2. Okay, all right. So x equals, of course, vertical. Hardest part's drawing a straight line here. Okay, x equals 2. I'm going to put a point at 2 on my x-axis, and I'm going to attempt to draw a vertical line through it. No promises. That's not too bad. Could be better, could be worse. So any questions on horizontal and vertical? Love it. Nice, easy Monday lesson. All right, let's take a look at these last two. An equation, horizontal line. So horizontal lines always go left to right. They always hit your y-axis. So they're y equals, and you better hit your -2 there. And last but not least, graph your y equals -1. So horizontal. Clearly too easy, we got it. Any questions on horizontal, vertical? Man, what a great Monday.